When we think of the space race, we imagine brilliant mathematicians drawing elegant trajectories on chalkboards and brave astronauts stepping onto the moon. But long before a rocket can touch the vacuum of space, it has to get off the launch pad, and getting off the launch pad requires controlled explosions. Welcome to another episode of History Glitch, where we explore the moments when humanity's operating system completely crashes. Today, we are looking at the absolute madness of the chemists who invented rocket fuel. Based on the legendary and terrifyingly funny book Ignition by John Drury Clark, we are going to dive into the Cold War laboratories where scientists routinely blew themselves up, poisoned their own facilities, and created substances so dangerous that they defied the laws of common sense. To understand this glitch, you have to understand what a liquid rocket actually is. A rocket engine does not breathe air like a jet engine. It has to carry both its fuel and its oxygen supply, known as the oxidizer. In the 1950s, the United States and the Soviet Union were desperate to build missiles that could fly faster, further, and carry heavier payloads. The mathematicians could design the rockets, but they handed the real problem to the chemists. The chemists were told to find liquids that, when mixed together, would produce the maximum amount of energy possible, a measurement known as specific impulse. And this is where the history glitch begins, because the chemists quickly realized that any chemical containing that much raw energy was fundamentally unstable, toxic, and actively trying to kill them. John Drury Clark was one of these mad scientists. He worked at the Naval Air Rocket Test Station in New Jersey, and his laboratory was essentially a bomb factory. The early days of rocket chemistry were not about precision, they were about trial and error. Mostly error. They started with relatively tame substances like alcohol and liquid oxygen. But that was not powerful enough for the generals. So they moved on to hydrazine, a chemical that is hypergolic, meaning it catches fire the instant it touches an oxidizer without needing a spark. Hydrazine was great for rockets, but it was highly toxic and prone to exploding if you looked at it the wrong way. Then they experimented with fuming nitric acid, a substance so corrosive it would eat through normal metal tanks in a matter of hours, dissolving the very missile it was supposed to power. To stop it from eating the rockets, they had to add hydrofluoric acid to the mix, creating a brew that could instantly melt human skin and bone. But the generals still wanted more power. This led the chemists to the holy grail of rocket oxidizers, liquid fluorine. Fluorine is the most reactive element on the periodic table. It wants to combine with absolutely everything. If you spill liquid fluorine on the floor, it will set the concrete on fire. If it touches water, it explodes. If it touches glass, it burns. Clark and his team had to design elaborate cooling systems just to keep the fluorine from eating its own containers. The glitch here is the sheer hubris of attempting to harness a chemical that nature clearly intended to remain untouched. But the absolute pinnacle of chemical madness, the ultimate glitch of the rocket age, was a substance called chlorine trifluoride. When John Clark wrote about chlorine trifluoride in his book, his advice to anyone who encountered it was simply a pair of good running shoes. Chlorine trifluoride is a chemical so aggressive that it makes fluorine look like a toy. It is a hypergolic oxidizer that will instantly set fire to things that are already burned. It will ignite asbestos sand ashes and test engineers. During one infamous accident, a ton of chlorine trifluoride spilled in a facility. It burned straight through a foot of concrete floor and then burned through another 3 feet of gravel underneath the concrete, releasing a massive cloud of lethal gas. The scientists were operating in a culture of extreme danger, where catastrophic explosions were casually referred to in official reports as anomalous thermal events or unscheduled rapid disassemblies. They were basically mixing the most toxic substances in the universe in metal buckets to see what would happen. There were projects involving liquid ozone, which had a nasty habit of randomly detonating with the force of dynamite for absolutely no reason. There was Project Zip, which tried to use boron-based fuels. The boron fuels burned with an incredibly bright green flame, but they produced a sticky, toxic exhaust that glued jet engines shut and poisoned the entire runway. The United States government spent hundreds of millions of dollars over a decade trying to make boron fuels work before finally admitting it was a complete and total disaster. The history glitch of the rocket propellant era is that we eventually reached the moon not by finding the perfect chemical, but by giving up on the perfect chemical. The chemists realized that the most powerful fuels were simply too dangerous for human beings to handle. When NASA built the Saturn V rocket to take Apollo to the moon, they did not use liquid fluorine or chlorine trifluoride. They used highly refined kerosene and liquid oxygen for the main stage. It was a compromise. It was not the most powerful fuel theoretically possible, but it was a fuel that would not melt the launch pad or dissolve the astronauts. John Clark's book is a hilarious and terrifying reminder of the cost of progress. It shows us that the path to the stars was not paved with just clean math and shiny metal. It was paved with toxic green clouds, melted concrete, and brave, slightly insane chemists running for their lives from their own experiments. It is the ultimate example of humanity trying to hack the fundamental laws of chemistry and chemistry fighting back. So the next time you see a rocket launch perfectly into the sky, remember the hidden history of the people who figured out how to make it explode in exactly the right direction.